Again, I want to give everyone a warm welcome here today before we get started, especially our attendees from Wisconsin. Whether you're joining us live or on demand, this webinar will be available within the next 3 to 4 hours on demand. And I want to welcome all of those folks from Wisconsin. Your account manager is Holly Koob, and she has a contract in place with CISA statewide purchasing in Wisconsin, allowing all schools and districts additional discounting on fast forward licenses. There's many schools and districts around the state, including Green Bay, West De Pere, Pulaski, Akanto, Burlington, and even CISA 3. ELL students are already using fast forward very effectively with struggling students, including special ed, Title I, and more. So we're very excited to welcome our Wisconsin attendees, and feel free to contact us about anything regarding CISA either during or after the webinar. And I would like to welcome our presenter here today, Dr. Martha Burns. I have been working with her for almost 19 years, which doesn't seem possible. Not even like remotely possible. But I learn something new every time I listen to Dr. Burns, and it's very exciting to have her back with us today. She's an adjunct associate professor at Northwestern University and has authored 3 books and over 100 journal articles on the neuroscience of language and communication. Dr. Burns' expertise is in all areas of learning, such as language and reading in the brain, the bilingual brain, the language to literacy continuum, and the adolescent brain. Dr. Burns is a fellow of the American Speech Language Hearing Association, or ASHA, and the director of neuroscience education for Scientific Learning Corporation. Please help me welcome Dr. Burns.
Oh, thank you, Carrie, and welcome everyone. It's delightful to have you today on our discussion of the effects of poverty on school success. You probably know, if you're in the United States, I know several of you are overseas in Europe and Australia and other places, but we in the United States have an increasing rate of poverty. The share of students who are eligible to receive free or reduced lunches from 2012 data, so it's 5 years old. There'll be new data coming out relatively soon, but the source was the Southern Education Foundation, and you can see that a lot of the schools in the nation have over 50% of their students on free or reduced lunches. So the number of students who fall below the poverty line in the United States has increased dramatically and is impacting our educational system. Now, not all of you are in the United States, and some of you are also in the United States working in different settings, so it helps me to know what are your students' greatest area of need. I assume most of you have students that have relatively high levels of poverty. That's why you are attending this. So would you say that your greatest needs of those students are their working and attentional abilities, perhaps some of the behavioral issues that they have? Do you have English language arts problems with the students? Are they having trouble with vocabulary or reading or writing? Or how about math or science or STEM subjects, or just something else? Just take your cursor and click on the circle that would seem most appropriate for you, then submit the form. You just press that little black submit button on the lower right-hand corner, and we'll take a look at our results in just a minute. I'll give you just a second to click it. And so the vast majority of you are saying really they are having trouble with English language arts, they are having some behavioral issues and working memory and attention issues. And that's pretty much mirrors the research, actually, that I'll be sharing with you. Those are the factors that have been showing up in the research that's been going on over the last 5 or 6 years. So to get started with that research, we're just going to go through a few key points. We're going to start with the effect of poverty on language itself. That is research that's 2 decades old but has been corroborated several times. It was the original research of Hart and Risley. We're also going to look at how income affects cognitive functions like attention and memory, so it's very appropriate that many of you are seeing those kinds of factors in your students. And specifically, memory and attention, but we're going to look at other cognitive skills as well, like processing speed and perceptual skills. We're going to look at the stress associated with poverty and the relationship between stress and poverty, because we know that stress itself has a toxic effect on brain maturation or on educational achievement. So we're going to kind of sort all of that out. We're going to look at the difference between males and females and the impact of poverty. We're going to look at our English language learners and their kind of several factors affect them, so I say triple jeopardy, but many of them have the language barrier, of course, but they also often come from homes of poverty. And then there may be unidentified learning disabilities if it's difficult to test them in their native language. Oops, and I left off the last one. I'll go back to that. That just came up very quickly, so I'll just go. But the last point, help. Try it one more time. I'm just going too fast on the last one. So the last point is that we're going to be looking at the Fast Forward program, Reading Assistant as well, and how that can help to turn around some of the effects of poverty. And I think that's why you're all here today. So. But let's start with the Hart and Risley research. It was published originally in 1995, so it's now 23 years old. And the term that they used was, the terms they used based on SES were children who came from homes where there was a professional, at least one professional in the home as a parent, children who came from working class families, and children who came from families that were receiving welfare. We don't usually utilize welfare as a dividing line anymore. We usually just use levels of income and other issues in terms of education. But what we noticed from that research initially was that students who come from your homes, everyone who's listening to this is a professional, are exposed to 45 million words by the time they're 44 years of age, 48 months. And if you just take the red line where it is for the children below the poverty line, and you trace that back to the left and till it intersects or would intersect. If you start at 48 and you just go all the way back to the blue line at that same point, that would be about 12,000 words exposure. That 12,000 word exposure is what a child from your home would have been exposed to by about the time they were 9 or 10 months. Now, the reason that that's so important is the brain is an experience-dependent organ. The way that the brain wires itself, the way it organizes itself, the way it prioritizes in the organization and consolidation is based on the amount of experience a child has. So obviously, if a child is starting school at 4 years of age, or preschool for sure, and they've been exposed to the same number of words that a child in your home was exposed to at 9 or 10 months of age, that child has really had a limited amount of experience with language, and that's going to affect their ability to respond to any kind of verbal directions, any kind of verbal instruction. And we know that when children begin with lower oral language skills, and this is Hirsch's research just a year later, 1996, but still 2 decades old, we see that when children begin kindergarten with low oral language skills, that the difference in their reading age level and reading achievement accelerates and widens as they go through and course through the educational system. So by the time they're in the 8th grade, by the time they're 13 years of age, there's a almost 5.5 year discrepancy or difference between children who started school with high oral language skills versus those who start with poor oral language skills. And what that tells us is how dependent our educational system is, and on learning to read, on the underlying language system. Now, we've known that language difference for several years, as I said, but recently, more recently, Kimberly Noble, starting in 2005, so now we're a little over a decade ago, did research showing that children who come from homes of poverty also have effects on aspects of cognitive functions other than language. And what you can see in this chart, the size of the bar is the effect size. So how much effect does poverty have on language? And we know it's huge. And if we use that as our benchmark, if we say, okay, that's a 1.0 effect, then what are some other cognitive areas where we see effects? And you can see that the red, I've circled the red and green there, working memory and cognitive control. Cognitive control is a psychological term. It's used a lot by social workers and psychologists, and we can think of it as paying attention on demand and self-control. So essentially, cognitive control is executive function, but executive function from the standpoint of resisting impulsivity and being able to attend on demand and being goal-oriented. And you can see those are huge effects. General memory also is affected by poverty, and you'll see why when we get into the toxic effect of stress. But what stress does is it overrides any long-term memory. So you're going to remember what was stressful and forget things that happened to you during a day that was stressful. And so from that standpoint, it affects long-term memory as well as working memory. And then it also affects some visual and spatial cognitive skills as well. And, of course, those are important for math, but those are important for reading as well. So that research was seminal in 2005. And since then, what the researchers have done is looked not at the cognitive skills per se, because that could be misleading. People could think, well, maybe the children just wouldn't have had that high of ability to start with. And so instead, what we've done is seen some research in longitudinal studies looking at the effects of poverty on brain maturation itself. And I want to emphasize that this is brain maturation. This is not brain anatomy, physiology, or potential. It is physiology, but it is not. It is the way the brain has shaped itself through experience. If you have less experience, the brain has less experience to make connections. And one of the early studies in this particular area, you can see in this particular chart, and this was Hanson et al., published in PLOS One, which is an open access journal. And that was published in 2013, so it was published 5 years ago. And what they looked at was the thickness of the cortex. And I'll explain why that's a variable of maturation. What you can see is the gray line here, the low SES line. Actually, the children at 5 months of age in the lower left-hand corner have greater cortical volume than total gray matter than the mid-SES and the high SES. But what happens is you can see that they're kind of equaling each other by about 7 to 8 months, and then by the time you get, except for the blue, the mid-SES, they kind of catch up with the volume of the brain around a year. But after a year, what you can see is that the high SES and mid-SES children, because of the high experiential levels that they have probably with language, with other kinds of social interactions, etc., the brain takes off and it matures much more rapidly. And the reason that's maturation, I'll just explain briefly, but what you're looking at when you look at total gray matter, just to remind you, that is neuron cell bodies, but it's also dendrites. And dendrites grow based on experience. So every time you learn a new word, you get new dendritic connections. Every time you learn a new concept, you get new dendritic connections. So dendritic growth is a reflection of experience. And you can see then the effects of experience and how the children start out with equal potential, but as the experience differs, so does the brain maturation. Now, Kimberly Noble went back and looked at the brain after her 2005 study, and she did that just 3 years ago in 2013. And what she looked at was family income, parental education, and brain structure in a little bit more detail. And what she looked at was regions of the cortex that seemed to be maturing differently. And what she found, number one, is that when children come from lower income families, there are differences in brain areas, and I'll explain which areas those are, that are pretty profound. There's very little difference if you compare middle income and high income students. But so among children from higher income families, similar income increments were associated with smaller differences in the surface area. But what happened was the children who were most impoverished, and here you see the picture of a little homeless child just to bring that home, but it implied that income relates most strongly to brain structure among the most disadvantaged children. And again, most of the researchers believe that has to do with a combination of stress and a lack of varied stimulating experiences in their world. So let's look at the effects of stress and try to sort out what stress is doing. The term that most researchers are using now to differentiate stress, that it affects brain maturation from other stress, because stress is good for you. Stress isn't bad for you. The worst thing you can do is live in a totally stress-free world. You just wouldn't be stimulated. So the term that's used now is toxic stress. And toxic stress itself is probably one of the most prominent factors in brain development. And just, again, to bring that home to you, if you think about the last time maybe you did some silly thing, left your keys someplace that you shouldn't have left them, or locked yourself out of your house, or forgot to take a very important document with you on a trip or something like that, it was usually when you were under a high amount of pressure. And that's the effect that stress has. Stress literally shorts out cognitive processes like being goal-oriented and thoughtful and purposeful, and because your body's trying to respond to the stress itself. Now, keep in mind, poverty does affect language exposure, as you see on this chart, on this slide. You often have parents that have variable job hours. You may have only a single parent home, which affects how much stimulation the child gets. And there might even be other factors too, like nutrition. But when we look at stress, then what we want to do is look at its effects regardless of income and see if we can sort out, okay, how much of what we're seeing is related to stress, and these low-income students, how much of it is related to other factors, perhaps like nutrition or lack of stimulation. There's a wonderful the Harvard Developing Child website at Harvard.edu has this pamphlet you can get. It's a working paper published by the National Scientific Council on the Developing Child. But just looking at stress itself on the developing brain and the research along that line. And when we go to that research, it's important to understand now, we've been talking about the cortex, but let's go into the limbic system, because it's the limbic system that responds to stress. The limbic system drives our emotions, and it becomes more intense and more pronounced at puberty. If you have an adolescent that you work with, or several adolescents, or an adolescent in your home, you know they're just more emotional. They cry more easily. They become angry more easily. And it isn't that an adolescent has a half-baked brain in any way. It's just that evolution was designed differently from that or a child or an adult. An adolescent is developing what we're going to call emotional regulation. And emotional regulation is where emotions are recognized and they're strong, but the frontal lobe will gradually start to exert some control over those emotions. Now, the frontal lobe doesn't make your emotions go away, but what the frontal lobe does as it matures is it allows you to deal with the emotions. If somebody is hurting your feelings, or if you're very frightened, it allows you to respond in a way that isn't going to be injurious to you. And that's what this maturational process is all about. And it's no accident that in most societies, especially hundreds of years ago, the warriors were young men, young adolescents, because they had this heightened emotional part of their brain. They didn't think it out a lot, so they weren't as afraid to go into battle. They weren't as afraid to fight others. They were driven by emotions. As we get older, we become aware of how much trouble we can get into. That's our frontal lobe, and it starts saying, "Whoops, hold on, that's not a good idea." So stress has the effect then of negatively affecting this relationship between the frontal lobe and the emotional part of the brain, and that's really what I want to spend a little bit of time with. Now, as I said, stress itself is good for you, so you need a little bit of stress in your life, or you become way too complacent and your brain isn't experience-based anymore. It's just resting all the time. So as long as we have a little bit of stress and it occurs over a limited period of time and we have time to recover, so I might work very hard at work and traveling and speaking, but then as long as I can come down after that event is over and I can relax and read a book or enjoy dinner with my family, then that recovery is adequate and it enables us to handle the stress and for the stress to be a positive as opposed to a negative. Now, with children, what's important is that the stress occurs in the context of ongoing supportive relationships with adults. So a child might have a terrible day at school, there might be a bully, they might do poorly on a test, but when they come home and there's support at home and they feel supported, then that stress eases, just like it eases if we get to sit down with our family members for a nice dinner after a stressful day as well. But stress does have major effects on brain maturation. There's a wonderful book by Sapolsky, who's at Stanford, that was written last year. The title of it is Behave, and it's actually a bestseller. He's a neuroscientist. But he talks about this inverted U effect of stress on brain maturation. So if you have too little stress, which you can see on the left side of this chart, understimulation is the term that you see there, then that's deleterious. It actually affects brain maturation. We see it in aging adults who are in extended care facilities, for example, where they're just not getting enough stimulation and they're starting to have extreme memory problems and all sorts of organizational issues. And then on the right side, you see the effects of toxic stress and overstimulation. And then right in the middle, you see what we're going to call stimulation, and that's also what Sapolsky uses. So, yes, you need a little stress. A little stress keeps you going. A little stress keeps you excited. A little stress keeps you purposeful, and it keeps the brain in a way in balance, and it also drives the brain to change in meaningful ways. So sustained stress is associated with a set of hormones, actually, glucocorticoids they're caused. And the glucocorticoid levels, when they increase dramatically, start having negative effects on brain. Eventually, if it happens toxically and continuously, the glucocorticoids will lead to depression and anxiety. And those are two disorders associated with elevated glucocorticoid levels. So it's toxic stress then, which is strong, frequent, prolonged activation of the body's stress management system, stressful events that are chronic, uncontrollable, and uncontrollable is a key there because that's what we see in poverty. We see children who go to school, they're not doing well in school, it's hard, they don't get it, they go home, there's violence in the home, there's a lack of a feeling of comfort in the home and safety, and so they just have this chronic, uncontrollable stress. And if they don't have access to caring adults, then often that continues and becomes exacerbated. And that's especially true if when the student goes home, there's abuse or other kinds of stressful situations during the real sensitive periods of brain development. So it's extreme exposure to toxic stress that changes the brain's response system. And if you just go back and think again of what we said at the beginning, that the brain is an experience-dependent organ, what's happening is if a child's under tremendous stress, then the brain is going to respond very quickly to a stressful situation, much faster than it would with you or me, because the brain is anticipating, if you will, that this child's in a stressful world. So it doesn't take much, a tap on the shoulder, and the child might swing around and just slug somebody because they're hyper responsive to anything that might pose a threat to them. And not only does the brain respond at a lower threshold, it activates more frequently and for longer periods. So once a child's gotten hyper and become very upset about something, then that they will stay that way for a longer period of time. It's like revving up a car engine for hours every day. And that wear and tear, which it is on the brain, increases the risk of stress-related physical and mental illness later in life. And so the biology is that there are essentially two chemicals produced in the brain, two glucocorticoids associated with this stress response. The cortisol is the glucocorticoid that it increases your responsiveness of the hypothalamus and the adrenal gland. And then in addition, you get adrenaline, which is produced by the adrenal gland directly. And adrenaline, you all know, increases your energy level and increases your attention, but increases your attention and energy for solving the stressful situation, not for other things that might be going on in the environment. They're both produced under normal circumstances, and they help prepare all of us for coping with stressors. It's when they're chronic. Now, some newer research, Jimenez did a very thorough study of over 1,000 children nationwide, where he didn't look at poverty, he looked at what we now refer to as ACEs, adverse childhood experiences in the environment, experiences that would cause toxic stress. And he looked at two major variables. The first major variable was child maltreatment, where the child is physically abused. It could be psychological abuse, it could be physical abuse, it could be sexual abuse, or it could be neglect. And then the other variable was household dysfunction. Is the mom depressed? Is there substance use in the home? Is one of the parents incarcerated? Is there violence toward the mother? And by the way, I learned recently that they looked at paternal depression and it doesn't have the same effect. So these were the major variables that they looked at, that they labeled as ACEs. And if a child had any one of these, according to usually the social worker who was evaluating the child for this particular study, then they totaled the number of ACEs for all of these 1,000 students. And you can see that 451, a little over a third of them, had no ACEs, but 2/3 of them had one ACE or more. And you can see that a pretty large percentage, 10%, over 10%, had two ACEs, and almost about 8% had three ACEs. And then what they looked at is how that affected, and again, we're looking at effect size here. So what was the effect size of these adverse experiences on language and literacy skills? What was the effect size on science and social studies or math? And they asked students or the teachers to rate the students based on their language and literacy, science and social studies or math issues. And you can see that there's almost a perfect linear relationship, especially for language and literacy, which many of you have already said in that first poll question, and then also for math, that the more ACEs a child has in their environment, the more it affects their academics. But it also affects cognitive skills like attention. It affects their social interaction. That's why many of you checked off behavioral issues. And oftentimes the children are more aggressive because they're acting out more quickly and responsively. And so now the newer research, just the last year or so, is focused on the adolescent brain, because what we've started to realize is as much as these ACEs affect younger children and as much as poverty affects younger children and stress, it's cumulative. So the older a student becomes, the more we see the effect. In June of 2015, there was this great article from the journal Mind and Brain of Scientific American showing this mismatch in the adolescent brain between the limbic system, that purple area that we talked about that responds to your emotions, and then the prefrontal cortex, which is going to enable you to have some regulation over your emotions. And again, it doesn't mean you suppress your emotions, it just means how you handle them. Do you handle them in a constructive way, or do you yell at somebody, or do you start a fight, or do you do something that could be classified as a behavioral problem? And then very recently, just March of this year, in the journal Nature Neuroscience, Lucy Folks and Sarah Jane Blakemore, who've been looking at adolescent brain maturation for years, published a wonderful study on individual differences in adolescence based on poverty alone. And they looked at the executive function part of the brain, working memory, attention, processing speed. And again, many of you are seeing these working memory, attention issues, and processing speed is just where you're slow on the uptake. It just takes you a few minutes to respond to almost anything that's going on cognitively. And then the part of the brain, that turquoise part of the brain that's so important for oral language. And what they found was that in students of poverty, these are the two parts of the brain that are the most affected by poverty. And what's interesting is this particular chart that you see here. At the top, what you're looking at is that blue area of the brain, and at the bottom, what you're looking at is that language part of the brain. And what you see is that if you look at the graph, you're looking at the volume of those regions. And remember, the volume of those regions is going to be related to experience. And you can see that high SES students, the volume of the executive function area and the language area increase over time. Mid-income students, it stays kind of stable, but the low-income students, it's really declining from the time they're 4 years of age to 18. So these students are not benefiting from our educational system in terms of language and executive function. So the question is then, what do we do about this? And understanding that a lot of social emotional learning, which is a huge buzzword right now in the United States. I'm not sure if it is in other parts of the world, in Ireland or in Australia, but looking at the child as a whole human being and looking both at their learning capacity and their social emotional or behavioral strengths, we're starting to realize that a child with a history of trauma, toxic stress, children who are English language learners or second language learners, and aren't showing progress from other interventions, this is all tied to the poverty and the stress. So for our most vulnerable students, then, we in the United States have now an Every Student Succeeds Act that requires the schools to demonstrate growth for these students. And so it's imperative that we understand how we can, if education isn't reaching them, which the Folks and Blakemore research suggests that adolescents are actually decreasing in their language and executive function skills, how can we reverse that? And that's especially true also for the children who are trying to learn in a language other than their native language. In the United States, are English language learners especially. And we know that ELL issues extend beyond the language barrier. We know that when children are exposed to a second language late in life, which is what you see on the left-hand side of this particular slide, and you look at the part of their brain, it's called Broca's area, that actually is speaking that second language and the first language. The second language is yellow, the first language is red. You can see that late bilinguals who start learning a second language after they're 6 years of age have almost an equal area for each language over time when they're adults, but the area is relatively small and they're totally separate. Child is either thinking and speaking in one language or thinking and speaking in the other. Whereas if you look at early bilinguals, what you see is there's a huge overlap. The area itself for language, this Broca's area, is much larger, and there's tremendous overlap so that this child doesn't have to translate every time they hear a word in one language or another. It's as though they have one big, giant language. That's the goal. If we can improve the language skills of these children very quickly and very efficiently, we can get them performing much better in the classroom, and we can get them responding better to our instruction. We also know that in the United States, especially right now, the students have the added stresses that go along with being perhaps undocumented, or their parents being undocumented, the fear of deportation. And they may have learning disabilities, as we said, that are difficult to diagnose. So as we get into, okay, how can we reverse this? How can we reverse the effects of stress and poverty? Let's just look at what you all are facing in terms of the kinds of interventions you now are using. If your students of poverty are being tutored essentially in small groups, that would be the first one. If you're using what we call ed tech, or computer-based interventions for some of these students that are really struggling, that would be the second area. If your students receive the same instruction, but you just may have no specific intervention for students of poverty, but you perhaps have extra time that is given to them or something like that, but they all have pretty much the same instruction, you would click that one. And if you have some other kind of combination, you would click that. Look at those, press your submit button. I'll give you just a minute, and then we'll take a look. And many of you are doing small group reading interventions, especially with your students, tutorial interventions, as well as ed tech. So let's take that and build on that, and let's look at the benefit that would be added if your educational technology had a neuroscience basis to it. And that was published, a very nice meta-analysis was published several years ago in the journal Neuron. And what these researchers looked at is they looked at what is the effect of utilizing neuroscience-based educational technology for, especially they were interested in early childhood. Can we, as they say, move from why to what and how? We know what's going wrong. We know that stress and poverty are affecting children's ability to learn. What do we do about it, and how do we move? And can neuroscience help us? And that was their goal. And what they found was essentially two major findings. One is that one thing we can do as educators or as interventionists is provide a positive experience for the students. We can be that adult that's supportive and that cares about education. So we can also enrich their environment. Remember that the brain is an experience-dependent organ, so the sooner we can get these children into environments where they're being stimulated with language, being stimulated with social kinds of interactions, those opportunities for exploration, social play, language, and then having a caring and positive relationship with adults can have a very positive effect. But also this whole idea of educational technology, especially if it is neuroscience-based, and that's, of course, where the fast-forward exercises come in because of their specific emphasis on language, attention, and memory, and their particular effectiveness on those cognitive skills. That's really what they're aimed toward. Another meta-analysis of the research then by Linen and Koala, published in 2015, said, okay, well, so why does neuroscience-based interventions, why would they be any different? Why shouldn't we just go with the interventions that we have that are largely tutorial in nature? And the difference between what I'll call a tutorial ed tech intervention, where the student is just doing more of what they do in your classroom, they're just getting to do it on a computer. Let's say they're learning to decode, and so they just have more activities, practice. It's kind of like a workbook on a computer. They're doing more and more decoding practice on a computer. How is that different from something that's neuroscience-based? And what this meta-analysis showed that the content of the intervention is very important, and I'm going to explain that in a minute, and also the fact that the results tend to be more long-lasting. So what the researchers found was that, first of all, you can, when you use a neuroscience-based intervention, you can look at the behavioral changes. You can say, yes, the child is reading better, or yes, the child has better fluency, or yes, their comprehension is improved. But you can also look at the brain function, and you can see, does their brain function after this particular intervention look more like the brain function of a child who's not struggling? So it gives you a two-pronged way as an educator to evaluate the value and the efficacy of the programs you use. You can also look at the regions of the brain that need to be built. So you can say, okay, I can see executive function skills in adolescents need to be built, children of poverty. I can see language areas. Do I have interventions that show me that those two areas are affected in a positive way? Because what that enables us to do is specify and target our interventions to the specific needs of the students that we have. So just to pull us into that then, how effective are your interventions right now? Would you say that you're seeing the students that you're working with, you're seeing more than a year's growth in their academic skills, especially the ones you highlighted to me, memory, attention, reading, language? Are you seeing a greater than a year growth? Because that's obviously what you would want if in a year if you're doing an intervention with these students and you want them to catch up. Are they not working quite as well as you'd like to and you would like something else? They're working for the majority of your students, but you still have some students who are just really struggling that you're not able to reach. You're not quite sure how they're working because you're not the person who's really in charge of doing the assessment, or something else. Again, just figure out which one of those seems to represent your particular situation, and you can go ahead and press your submit button, and then once you're done, and we'll take a look, and most of you are saying yes. And I would say this is pretty typical of most of the people I'm working with and speaking to, that I'm hitting a lot of the kids. I'm getting for a lot of the kids, but I still have this group of students I just can't reach. And then some of you have said, you know, I just don't know. I'm not the person who's really doing the evaluating. I'm not quite sure how effective they are. So let's look specifically at the effects that you could see with the neuroscience intervention. Fast forward, for example, that A is targeting specific brain functions now, cognitive functions. So it's targeting executive function, it's targeting cognitive skills. In terms of the executive function that Fast Forward targets, it includes memory, especially working memory. It affects attentional skills, and those, you see the arrows go back and forth because those are reciprocal. You remember what you pay attention to, what you're paying attention to, you're more likely to remember, and so on. So memory enhances attention. When you're learning it and you're holding on to it, it increases your ability to sustain your attention. Vice versa, when you're attending, it improves your ability to hold on to it. But then this whole issue of processing speed, getting these brain fiber tracts that are sluggish and moving slowly and easily interfered with more efficient, and that's brain efficiency. And then the skills that are so important for math and reading, especially sequencing skills. So if we want to target that as opposed to just utilize ed tech that is what I would call supportive and tutorial, then what you end up with neuroscience-based technology that targets the underlying capacities that are reduced in children of poverty and with some kinds of learning issues. And what you can see is you will get much more than a year's gain. In a year, this was a high poverty school district in Louisiana, St. Mary's School District, that started using Fast Forward in 2006. The orange line is the achievement gap you see there of that school versus the state average. You can see that the state average has increased over the last 10 years, but that particular school district not only kept up with the state average as it was increasing, but surpassed it and has now really taken a leap in 2015 to 2016, a dramatic leap in achievement. And what you see is it affects all areas of academics because you're working with the underlying learning capacities. You're working with attentional skills. You're working with memory skills and enhancing those and processing speed. So in a way, we could say you're making the students smarter. And so in all academic areas in that high poverty school district, instead of seeing the adolescents decline in their capacities, we see them increase in their capacities. And so where that takes us is that these are game-like activities. They look like games to the students. It looks like they're doing fun activities, but in reality, what they're doing, you can see the fish over on the left-hand side. You see a pelican, and you see the word political fly across the page. It's moving from left to right. It's working on tracking skills, left to right tracking skills. It's working on rapid identification of sight words. It's working on being able to identify words quickly and easily, so it's working on fluency as well as comprehension. You see some of the comprehension and some of the vocabulary exercises. And so you're multi-training, you're multitasking the brain. You're getting the brain to work on lots of different underlying capacities in a single session. And what we see then, and we can go back to that adolescent brain that we saw, that Folks and Blakemore slides, where the red circle was the frontal lobe, and then you're looking at the language areas of the brain, that more that blue area, and you can see that in typically reading children, and then also in children who don't come from homes of poverty. What you see is those areas are lighting up when the students are doing a phonological awareness task. This was 35 students that were second graders. And then you see the children with dyslexia, but this could also be children of poverty where those areas aren't lighting up. And the reason they're not lighting up is that those fiber tracts and those particular parts of the brain are just not responding appropriately because of maturational levels. But within a very short period of time, in the case of this research that was done originally at Stanford and then replicated in Gabrielli's lab, several years later, you can see that the areas of the brain become active. So what we've done is we've reversed the effects of poverty and created the regions of the brain have reached the maturity level that the student is ready to learn to read. Now, it's important to keep in mind these students are still going to need to be taught. This isn't changing the education that the students need. What it is doing is providing them with a level playing field and a brain capacity that enables them to learn easily, just like all the other students. And we know from Carol Dweck's research that when children believe they can learn, when they believe that they're just as smart as the other students and that it's school that makes you smarter, growth mindset is the term, of course, Carol Dweck uses, that they show much greater achievement than students who think you just come in and you're either smart or you're not smart, and if you're not smart, there's not much you can do about it. So let's summarize and just conclude with what we've said today that we all know now as neuroscientists. The human brain is an experience-dependent organ. And so if we have early childhood experiences that are supposed to be preparing the brain for school, but the students just aren't getting those experiences, or in a toxic world where that's interfering with brain maturation, then our job as teachers, which is to build and change brains, that's the main goal that we have, is impaired because we're having students in our classroom that aren't ready. They just aren't ready from the standpoint of brain maturation. And then we have other factors interfering, like stress. But we do know all children can achieve. We do know that those who begin at a disadvantage can still see those parts of the brain mature if neuroscience-based approaches are used to remediate the underlying cognitive issues. So with that, we have concluded our talk. We'll open it up for questions and answers. And again, I think Carrie's going to come on and thank you from the Wisconsin educators for attending. And Carrie, you can take it over from here.
That was excellent, Dr. Burns. Thank you so much. We got a lot of questions to go through. We've got about 12 minutes before we get to the top of the hour. We'll end right around that time. First question that I got, and I thought this was a really interesting question. Someone asked, is there any differentiation in poverty? Say you're talking about urban poverty in various regions. Let's use the United States. I know we have attendees from all over the world on this webinar, but let's just use the United States since we're based in the United States. Urban poverty versus, say, rural poverty. Like I grew up in a pretty rural area in Maine, which there were a lot of poverty in that area in Maine, versus, say, you're living in poverty in New York City or the Bronx, or, is there a difference between the two, rural versus urban?
That's a really good question. When Kimberly Noble first did her original research on cognitive differences, she focused primarily on urban poverty, but since then, the researchers and Kimberly Noble as well have realized it's important to also look at rural poverty. And rural poverty can be just as entrenched. It often is not tied to racial differences the way urban poverty sometimes is to minorities. But we see exactly the same effects. So there is no difference between children's cognitive skills, brain maturation, that we can relate to racial differences, to ethnicity differences, or to rural versus urban. Poverty and stress go hand in hand, and they seem to be equally causing equal effects, at least from cognitive maturation standpoint, in both urban and rural poverty. Now, I will add, I travel around the country in the United States quite a bit, and different regions have different issues. For example, I did a tour through Tennessee in the United States, and that was rural poverty was huge there, and some of their issues were related to methamphetamine use in very impoverished areas, which you might not see in another region of the country. But the interesting thing is when Jimenez looked at adverse experiences, ACEs, and then Noble's more recent research where she's looked at both urban and rural poverty, the effects are pretty much the same in terms of academics and cognitive skills.
Interesting. Okay, so now here's another really interesting question that I thought was fascinating when I read it. Any indication that an early change in income group, say you're poor, you go to rich, or you go rich to poor, does that change the meaning of this research?
Oh, well, that's a good question, and as far as I know, that has not been looked at. So I don't think it happens very often just because poverty tends to be entrenched. If children come from a low-poverty home, it's very difficult for them to break out. But what I often say to school administrators, and it's true, is that the path out of poverty is education. And so if we can educate these children, if we can break the logjam, if you will, that these kids are facing academically, we could have some dramatic reversals in the economics of some of our population, and it would be really interesting to study that. So that's a very, very good question.
Okay, so next question is, does the gray matter, and this question came in, I want to say we're about a quarter of the way through the webinar, so we weren't too far along in the webinar to kind of refresh your memory of what we talked about.
Okay, yeah.
Okay, does the gray matter simply not grow because of interaction with language before and after birth?
Yeah, so gray matter, just as a reminder, your neurons, you're born with all the neurons you're ever going to have, essentially. You get a few more in your hippocampus. There are a couple places in your brain you get more gray matter as you age, but not very much. The changes are pretty small. And white matter, the long fiber tracts, are laid down. Think of those as the highways of the brain. And those highways of the brain are laid down pretty much in their rudimentary form before a child's born based on the genetics. And your genes also regulate the number of neurons you have, but we almost all have the same number of neurons when we're born. Then what happens is the brain starts shuffling everything around, and so based on experience. So unlike animals where the brain is pretty much developing based on genetics, based on just the development in general, in humans we are much more dependent on the environment for our brain to shape itself. And the brain will prune away connections that we don't use. It will increase connections that where we're learning new things and doing new things. And that is what increases the thickness of the cortex. So the cortex is experience dependent. Now the white matter is too. It becomes myelinated based on experience as well. So it's not just that the cortex is affected by experience, the entire brain is affected by experience. But the brain is shaping itself, if you will, so that you can adapt and be successful in your world. So it's trying to figure out what language do you need to know and shaping itself so that you can handle that language. It's trying to figure out what kind of survival skills do you need. Do you need to be a hunter-gatherer? Do you need to be a fighter? Do you need to be able to track? Do you need to be able to grow crops? Do you need to be able to read? And it's using all of that information to design itself, to shape itself, to sculpt itself. And so that's what the difference is. Children of poverty just don't have, they have experiences, but they're not experiences that prepare them for school. They don't have experiences of being talked to, but they also don't have experiences of group play and group problem solving and pretending and doing all those things that children do in nursery schools and in environments where they have the luxury of an adult guiding them through the day.
Okay, here is another question. It's a little bit different from our normal, kind of our regular questions, but I thought this was really interesting. You touched on this some, but do you know of any detailed research about how moving to a new country with a completely different language impacts students' brain development? Is there anything specifically for students in high school who do so? I just find that fascinating. Like if you're here in the U.S. and you move to China in your high school.
Yeah, okay. So that, again, that falls under the bilingual education research and the ELL research, essentially. And what we know is that I was just reading an article today. There's a journal called the Journal of Trends in Cognitive Neuroscience, and the article today was about how the bilingual, it's good to have a bilingual brain. It's beneficial for you as a young adult, especially. This specific article was exactly about that, and I can send you the link to that article so you can send it to the people and give it to them, because it just came out today, actually, in Trends in Neuroscience, in Trends in Cognitive Neuroscience. But what they said is, yes, it's beneficial to have a second language. It's beneficial to move from one language to the other if you use both languages. So let's say I'm an English student and I'm a good student and my parents move me to China and I learn Mandarin Chinese, but I'm still speaking English at home and I'm still reading English novels, but I'm also learning in Mandarin Chinese. As long as I'm using both languages and I'm fairly proficient in both languages, it's really beneficial to the brain. It really creates a brain that is very good at multitasking. On the other hand, if it's a conflict, if what happens is I'm good in English, but I go and I really can't learn Mandarin Chinese very well, I'm struggling in school, I'm in the lowest group, people are laughing at me all the time, then that creates a tremendous amount of stress, and that has negative effects on the brain and learning. Does that make sense?
Yes, it does.
And
Definitely.
so, and as I say, that what a timely question that article just came out today. So I'll send that link off to you when we're done.
Definitely. Please do, because I would love to share that. Okay, so time for 2 more questions. One is someone is mentioning the similarities between trauma and poverty in children is striking. This person is wondering, when children in poverty are experiencing toxic stress at home, does that not limit the effects of positive adult caring that is provided at school? How does that?
Okay, that's a really good question. And the research, that article I shared you from the journal Neuron, that particular research said that if a child can escape, if they have at least a few hours a day with a caring adult, that can override the negative effects that are going on in the home. And so one of the things I often say to people is if somebody's broken out of poverty, let's say you know someone and says, well, hey, I came from a very adverse home. My dad was never home. He was in the Army or he was sick or whatever, and my mother worked 3 jobs and was under a lot of stress and we had no food. But I broke out and look at me and I'm a superintendent. If you ask that person, if you just say to them, was there a person in your life that took you under their wing and that viewed education as important, they will say, almost always, yes, it was a coach, or I had a minister, or yes, I had the 2nd grade teacher who really believed in me and spent time with me to make sure I learned how to read, and I fell in love with books, and she would bring books to my house so I could read. And people will tell those stories. So the good news is that we can have an effect. Even though they're going home to a stressful environment, if they have a place that they feel is a safe haven and a place where the adult prioritizes education, that can ameliorate the effects, the negative effects of the stress in the home.
Awesome. Okay, so the next question is, let's see here, are there any fast-forward materials for a 19 to 22-year-old student?
Yes. So before we now have what's called literacy and literacy advanced, and reading 4 and 5. And before we had those, many of us, I included, used Fast Forward, the original Fast Forward, with young adults and with even older adults who'd had strokes. But we do have the specific products, literacy advanced, and then reading 4 and 5 are outstanding for use with adolescents and young adults. And I use them routinely with one of the populations I work with clinically, not so much anymore, but did for many years, was college level, high school and college level learning disabled young adults who wanted to get a college education but really were underachieving in high school and having trouble getting into college. Often they were in junior colleges. And what I would use is literacy and then literacy advanced, and then I would follow that up with reading 4 and reading 5, and many of them were able to show tremendous gains. And we actually have, if you go to our website, some great research. If you click on the research tab and you go to high school or adolescent research, you'll see we have some excellent research on adolescents. And some of them show remarkable improvements because they have been learning. They have been in school, they have been learning, they just can't show what they know. And after they go through Fast Forward, their processing speed improves, their language skills improve, their ability to show what they know improves, and their test scores go up dramatically very often.
Awesome. Okay, so that was our last question for today. If we didn't get to your question, we will follow up with you, or you can email it to us at webinars@scilearn.com. A couple of things before we conclude today. First, I want to thank all of our attendees. I know we had people from all over the world. I did have someone ask if Fast Forward was available in the United Kingdom, and yes, it is. I can connect you to the person who's our provider throughout Europe. We're in over 55 countries from around the world, so if you're in somewhere, we have somebody that provides Fast Forward somewhere near you. Then I do want to, again, thank all of our attendees from the state of Wisconsin. We are very excited that you joined us today, either live or recorded. And again, if you're interested in Fast Forward, you can talk with CISA, and they can give you information. And that website is CISApurchasing.org/fastforward, and it's at the bottom of your screen right now. The screen that we're looking at. And then after the webinar, I'm going to click to the next slide. You will be able to get the slides, certificate of attendance, and a link to the recording will be emailed to you within a few days. If you're here in the U.S. or in Canada, you can get sample exercises or request a free trial at www.scientificlearning.com/free-trial. So that will conclude our webinar for today. I want to thank everyone for joining us. Thank you so much, Dr. Burns. And
thank you.
Hope to see you all online again soon. Thank you very much for your time. Bye-bye.
Bye-bye.